Jenna, I think you're on mute.
Thank you. Hello, everyone. So we're going to give people a few minutes to join and get settled. So feel free to share where you're joining from today. Looks like we have Jack from the Bay. Bill is joining from Redwood City. Looks like we have Larry from Bogota. And Mark Antoine from Montreal. So thank you all for joining. So we're going to get started in just a few minutes. Looks like we have a lot of people from the West Coast joining. A few people from Texas. Looks like we've got most people in and settled and ready to go. All right, well, welcome everyone. Happy St. Patrick's Day to those of you that celebrate. I don't normally do anything, but I did make sure to wear my green IBM patent shirt for you all today. It's very lovely. I know it's light green. It's not really the Celtics green you're probably all looking for, but it's the only green shirt I could find. So welcome to our IBM Project Debater workshop today. So today we're going to be taking a look at sentiment analysis with Jupyter Notebooks and learning a little more about Project Debater. I have a few videos for you. We're going to get hands-on. I'll show you how to create a new project in Watson Studio. And so you have access to the data sets and to the notebooks, so you can run them yourselves, follow along as we go through them. And for those of you that aren't familiar with Project Debater, you're going to be pleasantly surprised, if I can speak. And I'm very excited to introduce any of you that aren't familiar with Project Debater. So just for reference, Project Debater is an AI technology that was developed by IBM Research with the goal of expanding human minds through impartial debate. So IBM researchers have been exploring the boundaries of AI by teaching computers to create better informed points of view. So the goal is to build a system that helps people make evidence-based decisions when answers aren't so clear. They're not just black and white. So to start, thank you all for joining. Thank you for joining the IBM developer community and myself and our speakers' professional communities as well. So go ahead and share a little bit about you in the chat. You can share as much or as little as you would like. I see you all have already shared where you're joining from today. So your name and pronouns, your title, company, or maybe you're in a school or a boot camp program, something you love, and a quirk. So I'll go first, lead by example. So my name is Jenna. My pronouns are she, her. I am a cloud developer advocate at IBM. I'm from and currently joining from Detroit. Technically, I'm based in Austin. Long story, storage unit. And I'm part of the New York team, which we're all kind of spread out now. So that's kind of cool. Something I love a really good tutorial. So something that's really dummy proof, that doesn't assume that I know where a button is. I really appreciate. Tell it to me like I'm a 6-year-old. That's the type of tutorials that I like to work through. And a quirk, so something that's uniquely weird or different about you. So I have an obsession with tuna melts and tuna sandwiches. It's kind of my shtick. If it's on the menu, I have to order it. And if it's bad, I judge all of the other food on the menu and the quality of the restaurant based on how much or how little effort they put into a tuna sandwich. So that's a little bit about me. So just to get started, if you scroll all the way to the top of the chat, I have all of the resources and links listed there for you. So everything, and I also have the link to the slides. So all of the resources I'm sharing with you, don't feel like you need to copy them all down. I'll also send up a follow-up email as well. But if you need to get access to anything while we're working along, you can scroll to the very top of the chat. So I have, first link I have here for you is the link to the slides. Feel free to comment anything that's not clear, anything that you'd like to add, you know, anything at all. I have comments on the slides for you all to comment as much as you'd like. The next thing I have here is the link to the IBM Debater notebook and dataset. So this is the URL to the dataset that we're actually going to be working with today, and I'm going to show you how to get set up with that. And then our facilitators today are going to walk you through what's going on in the notebooks and show you how to show you what's going on with all of the data and explain everything to you. So if you need to leave early, if you would like to share with someone that couldn't make it, yes, this event is being recorded, and the same URL you joined with today is where the recording will live. So once the event's over, it will just automatically convert into a live stream recording, and it will be here and available. Okay. So if you would like to follow along, and if you would like to run the data sets for yourself and check out the notebooks and play around with it a little bit, have some fun, you will need an IBM Cloud account. So this is the link, and again, it is at the very top of the chat, the link to sign up for an IBM Cloud account. It is a completely free account, a free account. So IBM has a free light tier account that gives you access to over 40 different services that we offer and more. And offerings we have, such as Watson Studio, have light tiers as well. So you can spin up different services and create projects with them and have access to our platforms and to our offerings completely for free using any of the light tier accounts. And all of that you can do with a free IBM account, IBM Cloud Account. So this is what it looks like. So if this is what you see, you're in the right place. So feel free to log in or create a new account. So again, this is, I introduced myself, so it's nice to meet all of you as well. This is my handle for all things social. So if you want to connect with me on Twitter or Instagram or any of the things, Twitch, this is my handle. So you can connect with me. There. So I'd like to introduce our two other speakers for today that are going to be walking you through our sentiment analysis data sets and notebooks. So I'd first like to introduce Sai Shruti. So Sai Shruti, if you'd like to introduce yourself, tell us a little bit about you.
Sure. Thanks, Jenna. Hello, everyone. I hope you all can hear me. So thanks for joining us today. And I'm Sai Shruti Swaminathan, and I work as a data scientist and I'm technical lead of open source machine learning team. Our group is called CODITE. It's Center for Open Source Data and AI Technology. And we work on contributing to open source project. We work with clients in the client in creating their data science solutions. And we have a lot of other branches that we work on, right? So just like on a high level overview of what our team does. And I'm so happy to be here and presenting one of our, like a top notebooks or the use cases that we have. And yeah, looking forward to the presentation.
Thank you so much, Sai Shruti. So now I want to introduce our next speaker. So Ewan, why don't you tell us a little bit about yourself?
Yeah, sure. My name is Evan. I'm a data scientist and also a PM of our IBM machine learning CODITE team. So our day-to-day job is to create machine learning and deep learning models. And recently we're focusing on creating Coursera cores. So one of the Coursera cores, data analysis with R, are pushing out in several months. And also something interesting about myself is I'm a big fan of Harry Potter, and that's basically the only movie I have ever watched because sometimes like studying all the time and not a big enthusiast of the other movies because I love Harry Potter too much. So yeah, that's it about myself, and hope you all enjoy today's talk.
Thank you so much, Evan. And yes, Harry Potter, definitely a plus from me on that. I love me some Harry Potter. So the next thing I would like to do briefly before we go ahead and get started is IBM offers a very wide range of educational resources and tutorials for free that are associated with learning badges. So there's a lot of e-learning badges you can earn that are accredited by IBM that are available through a platform called Acclaim. So the two that I have here for you, so I thought were the best fit for the topics that we're going to be talking about today. So the first badge is a set of three e-learning workshops, and when you're finished working through all of the content, you'll earn a badge for each piece of content you finish, and then once you complete all three, you'll earn the Data Science Foundations badge. So this is a really great resource if you're new to data science or you're looking to brush up on your skills and earn some badges to add to your social platforms to help you stand out with potential companies and recruiters. So this first one is the Data Science Foundations badge. second badge we have here is the Applied Data Science with Python. So this will allow you to get a little more hands-on. There's different courses and labs to create, to complete. Again, this is a set of 3 courses, so you'll earn a badge for each course, and once you complete, you'll have earned the IBM accredited Applied Data Science with Python badge. So highly, highly recommend. I do a lot of our badging myself. I think they've been really beneficial. I have all kinds of cheat sheets that I've created from working through the labs. So let's go ahead and get started. So first of all, what is a Jupyter Notebook? So for any of you that are new, so a Jupyter Notebook, which is what we're going to be adding our data sets to and working through today, it's just an open source web application that allows you to create and share documents. They contain live code, different algorithms and equations, visualizations, and different text and summaries about what's going on. So some use cases for Jupyter Notebooks are data cleaning and transformation, numerical simulation, statistical modeling, data visualization, and machine learning, and all kinds of other good stuff. So what are Jupyter Notebooks used for? So we went over a few examples. So what's nice with an IBM Cloud Account that I'll show you a little later in our talk when we get a little more hands-on, is that you're able to create Jupyter Notebooks within Watson Studio, and you don't have to use any external applications to do so. It's integrated within the IBM Cloud console, and it's accessible at any time. So you can access any of your projects, and including anything you do in Watson Studio, all within your IBM Cloud account. So let's talk a little bit about, at a very granular level, how Jupyter Notebooks work. So a Jupyter Notebook runs on a kernel. So a kernel is a computational engine, and what it does is it executes the code that is contained in the notebook. So the IPython kernel that we're going to be seeing a little later is going to be executing Python code. Kernels for other languages exist as well. When you open a notebook document, the associated kernel is automatically launched. And then when the notebook's executed, which you'll see, we can either run cell by cell or we can run all together. But the kernel is performing computational, it's performing the computation and then producing the results. So depending on what type of computations you're using, the kernel may consume a lot of CPU and RAM. And just keep in mind that the RAM is not released until the kernel is shut down. So if you want to get your computer running back like it should, you're going to want to make sure you shut that kernel down. Okay, so since we're talking about Project Debater specifically, and we're talking about sentiment analysis, what we need to focus on is what we shorthand with NLP. So does anyone know what NLP stands for? So natural language processing is what I'm going to give a little intro to you before we introduce IBM Project Debater, so that when we get into more of the details, it makes a little more sense. So natural language processing is technology used to aid computers just to understand humans' natural language. So natural language processing, short for NLP, as we saw, is a branch of AI that deals with the interaction between computers and humans using natural language. So the objective of NLP is to read, decipher, understand, and then really make sense of human languages in some sort of way that provides value. Most NLP techniques rely on machine learning to derive meaning from human languages. So what is NLP used for? So you may have already interacted with something that is using NLP. If you have used any type of voice assistant, Siri or Bixby or Google Assistant or Amazon Alexa, any of the things, these are all using NLP. So a typical interaction between a human and a machine using natural language processing would go as follows. So we talk to the machine then captures the audio. So the Alexa is going to capture the audio. The audio is going to convert to text. And then the text's data is going to be processed. Then there's going to be a data to audio conversion that takes place. That's going to allow the machine to respond to us by playing the audio file. So if we say, Alexa, what time is it? It's going to convert our audio to text. It's going to process the data. It's going to say, okay, it's 7:30. And then what's going to happen is it's going to convert that data to audio, and then it's going to tell us what time it is. So that's an example of how NLP works. Just a few notes here. So language translation applications such as Google Translate. Are examples of, this is a great example of natural language processing at its core kind of root level. So word processors such as Microsoft Word, or if you've ever used Grammarly, they employ NLP to check grammatical accuracy of text, or if you've used the little spell check in Microsoft Word. Interactive voice response application used in call centers to respond to centers' users' requests. So if you've ever talked to one of those annoying machines and tried to place an order, like I just did earlier, and it went terribly wrong, that's a great example, use case of NLP. And again, like we talked about, any virtual assistant applications. So we face a lot of challenges with NLP, right? So think about it. So why NLP is such a difficult problem in computer science? So it's actually the nature of human language that makes NLP difficult. So how many of you have ever studied a foreign language and then learned a whole bunch of exceptions for how to speak the language, right? So languages don't follow set in stone rules, which makes things very, very tricky. There's colloquialisms and different dialects and all of these really messy things. Human language is very messy. If we think about a computer program, we tell it what we want it to do, and there's no gray area. It knows exactly what it needs to do to execute any functions or processes we ask it to do. So the rules that dictate the passing of information using natural languages are not easy for computers to understand. So some of the rules can be high level and abstract. For example, when someone uses a sarcastic remark to pass information, right? That could be really tricky. That could, elicit a positive or very negative response depending on, I guess the individual's level of sarcasm. So on the other hand, some of the rules can be more low level. For example, using the character S to signify plural items. So if you place an order through an Amazon Alexa, it knows, if you want 5 apples, or you want an apple and then you say add 2, it'll say back to you, 3 apples. So there are some low-level language rules that are easy enough to apply uniformly for the most part with natural language. So comprehensively understanding human language requires understanding both the words, right, the actual vocabulary, and then also how the concepts are connected so that you're able to actually deliver the intended message. Humans can easily master language, right? But ambiguity and imprecise characteristics of natural languages are what make NLP difficult for machines to implement. So there's a lot of things that can get easily lost in translation. So we kind of talked a little bit about this. So how does natural language processing work? So what is actually happening is the application of algorithms to identify and extract natural language rules such that the unstructured language data is converted into a form that computers can understand, right? So if you speak something, it needs to actually extract the language rules so that the unstructured language that it's capturing can be converted into a form that the computer can actually understand, into something that is readable and that makes sense. So when the text has been provided, the computer is going to use algorithms to extract meaning associated with every sentence, and then it's going to collect the essential data from them. So sometimes the computer may fail to understand the meaning of a sentence, which can lead to some obscure results. So for example, I'm not sure why. When I was searching for NLP specific examples, I'm not sure why this is the one, but apparently something really funny happened in the 50s translating between English and Russian, which I've heard all kinds of things, but for simplicity's sake, there's a quote or a phrase that says, "The spirit is willing, but the flesh is weak." So, however, when the sentence was translated to Russian, right, and then back to English, they came out with "the vodka is good and the meat is rotten," right? So there's a lot of things there, spirit, obviously they took meaning a drink, and flesh they took for meaning meat. It's just an example of how easily context can be confused and lost. So techniques used in natural language processing. We have syntactic analysis and semantic analysis. And these are the main techniques used to complete natural language processing tasks. Oops. So syntax refers to the arrangement of words in a sentence so that they make grammatical sense. So in NLP, syntactic analysis is used to assess how natural language aligns with the grammatical rules. Computer algorithms are used to apply grammatical rules to a group of words, and then it derives meaning from them. So I don't want to go too deep. I have broken down some syntax techniques. I don't want to get too granular. I want us to have enough time to get hands-on with our data. So semantics refers to the meaning that is conveyed by a text, right? So semantic analysis is one of the most difficult aspects of natural language processing that researchers are still kind of working on. So it involves applying computer algorithms to understand the meaning and interpretation of words and how sentences are structured. So I have some, in the resources, I have some techniques for semantic analysis as well. So we're going to cover some of these as we go. So so some examples of natural language processing. So for instance, communication devices for people with disabilities, converting sign language to text machine translation. To text. Another example is machine translation of tech manuals and catalogs in foreign languages. So, such as using Google Translate, or I don't know if you've ever seen that little white plastic translator thing that you can speak into, and you can speak English into it and then push the button and it translates your English to Japanese or Chinese or some other language. Those are really cool. Another example is aircraft maintenance. So this is something that I found really interesting. NLP helps mechanics synthesize information from aircraft manuals. It can actually find meaning in verbal and handwritten reports of problems from pilots, which is actually really useful because their manuals are extremely large and it can take a lot of time to actually find what they're looking for. So they've been able to apply NLP in this instance, and I just find it really interesting. Okay, so NLU. So what is NLU? So NLU is natural language understanding. So the difference between the two, really NLU is just a subtopic of natural language processing. So natural language understanding involves breaking down human language into a machine readable format. So some interesting applications include text categorization, machine translation, and question answering. NLU uses grammatical rules and common syntax to understand the overall context and meaning of natural language. Beyond just the literal definitions, right? Like remember when we're talking about, someone using sarcasm or, conveying messages in different ways. So natural language understanding, the goal is to understand written or spoken language the way a human would understand it, right? So natural language processing, we're trying to make sure that the data is being received and understood in a literal sense. Natural understanding, we're trying to help a computer understand language the way that we speak to each other, which is extremely challenging. So NLU is used in natural language processing tasks like topic classification, language detection, and sentiment analysis, which we're going to cover today. So I think we kind of went over this pretty well. Some examples of natural language understanding, automated reasoning, automated routing of tickets, question answering. So what we're going to be hyper-focusing on today is NLU sentiment. So sentiment helps us quantify perception. So when a new product is released, organizations want to know how people are talking about it. Do they like it or do they hate it? Are they neutral? What we would want to do is we would want to be able to use natural language understanding sentiment feature to analyze how blog posts discuss different topics. So what we're doing here is we're analyzing the sentiment toward specific target phrases, like great, or maybe Rotten Tomatoes, or something. We can analyze the specific target and the sentiment of the entire document. Maybe there's some things that could be perceived as bad, but overall, it's a positive review of a product. So you can also get sentiment information for detected entities and keywords. And again, we'll go a little bit more into detail. So my phone, sorry, is listening and talking. Okay. Sentiment analysis, which is what we're going to be looking at, automatically interprets emotions within a text and categorizes them as positive, negative, or neutral. So by quickly understanding processing and then analyzing thousands of online conversations, sentiment analysis tools can deliver valuable insights about how customers view your brand and products. So this is, you know, taking Reddit posts or, you know, feedback in the App Store, things like that. Sentiment, and specifically targeted sentiment, helps us quickly understand this. So unlike emotion, sentiment breaks down into 3 categories: that positive, negative, or neutral that we were talking about. And natural language understanding offers multiple ways to extract sentiment. For instance, document sentiment, which is kind of that, what's the overall feeling. We have targeted sentiment, which is looking for specific, it's looking for specific phrases throughout a document. And then we have keywords and entities, which are looking for specific keywords, like good or bad. So this is an article that I shared in the slides. What I would like to do is introduce and tell you a little bit about IBM Project Debater. So IBM Project Debater has been in development since 2012, and it is IBM's next big milestone for artificial intelligence. So previous breakthroughs were, I don't know if you remember, Deep Blue in 96 to 97, and Watson on Jeopardy in 2011. So this is what it actually looks like. This is kind of a close-up. So it's kind of like a long, you know, I definitely don't condone vaping, but it looks like a giant vape pen with a little LCD screen in the middle that actually, you know, changes as it's interacting with you. So it's kind of like an audible measure. So this is what it looks like. It's actually pretty big. It's very tall, and it's kind of like a rectangular, slimish stick with what I look at this as kind of like its mouth. So think of a, you know, Bender from what you call it? Can't think of it right now. The robot. It's kind of like it changes like as it's giving a response. So what is Project Debater? I told you a little bit about it in the beginning, but it's actually the first AI system that can debate humans on complex topics. So Project Debater actually digests like massive texts, and it constructs a well-structured speech on any given topic. And then it delivers its speech with clarity and purpose, and is able to rebut its opponent. So eventually, Project Debater will help people reason by providing compelling evidence-based arguments and limiting the influence of emotion, bias, ambiguity. I think we see a lot of misinformation nowadays with social media. So this is something that could really help mitigate that. So what I would like to do is just give you an intro. This is just a quick, or this should be a quick intro video. Let's see if it's the right video. Yes.
I'm spending the last 8 years developing a machine that will be able to debate humans. And now we are going to have the first full live debate between the system and an expert human debater.
If you look at the history of AI, games really helped us make a lot of advances. Unlike games, real world problems, a lot of times they don't have a clear bottom line win. We have to step away from games. We have to step away from black and white challenges. So AI is now going to deal with the subjectivity of human reality.
You can draw the rules of chess. You cannot draw the rules of conversation. That's impossible.
How nuts is that it could take artificial intelligence
to teach us to understand other human perspectives better.
The magic of Debater is that it can argue on any topic thrown at it under the sun. It's a single debate. It's just one debate. In a single debate, many things can happen.
Who do you think is going to win tonight?
Well, what we really want is to create systems that work with us so that we can make better decisions. Ladies and gentlemen, here we go, Project Debater.
Greetings, Harish. I suspect you've never debated a machine. Welcome to the future.
Cool. So that was a little intro video to get you warmed up. I'm going to show you actually a clip of IBM Debater or Project Debater in action. So,
I'm spending the last 8 years.
I think we're stuck on a slide. There we go. Didn't want to let me pass. Okay. So this is supposed to be how. Interesting. How does Project Debater work? So Project Debater relies on 3 pioneering capabilities. So the first is a data-driven speech writing and delivery, which is also the ability to automatically generate a whole speech. Reminiscent of think of an opinion article, and it's able to deliver it in a persuasive manner. So the second capability is its listening comprehension, which is the ability to understand a long, spontaneous speech made by a human opponent, so that it's able to construct a meaningful rebuttal. So the third capability is the system's ability to model human dilemmas and form principled arguments made by humans in different debates based on a unique knowledge graph. So by combining the 3 core capabilities, it's able to conduct a meaningful debate with human debaters. There you go. So why is Project Debater important? Like, why is it such a big deal? So the rise of one-sided and doctored narratives is challenging, I think, most people globally today. So too often we talk past one another, over one another. We don't really listen to what each other are saying. So Project Debater is a smarter way to do that. So recent developments in language and reasoning in AI can help work out the problem with distorted facts to provide diverse and well-informed viewpoints, both the pro and the con, not a biased reasoning, but able to form well-informed viewpoints from both sides, on both sides. So the world, we get a lot of misinformation nowadays and superficial thinking. So Project Debater is really pushing frontiers of AI to facilitate intelligent debate so we can build well-informed arguments and make better decisions. There we go. So why teach a machine to debate, right? Like, why don't we just have one really, or 10 really smart people that just like have all the answers? So culturally, the origins of debate lie not in conflict and competition, but in democracy and discussion. So debate actually enriches our decision-making and helps people more clearly weigh pros and cons of new ideas and philosophies. So it actually is at the core of civilized society globally. So we not only debate others of our own opinions, but we also debate to understand and learn from each other's different viewpoints. So in the future, Project Debater team believes, and IBM believes, that that machines will be able to help humans with many important decisions that we make day to day. So we're thinking about how Project Debater is, listening intently and forming these arguments. You might think to yourself, well, how is this different than a keyword search, right? So a keyword search actually is going to bring back a collection of relevant documents, or it may just trigger a simple response that's already been prepared, right? Like it may pull up an article. And how do we know Project Debater is not just regurgitating an opinion piece or a research article, for instance, right? So Project Debater is actually developing a much deeper understanding of the topic at hand. So it's actually constructing a point of view based on its findings. And that's really difficult for a machine to do. So to construct the speech, it has to first remove all of the redundant claims so it doesn't repeat the same point again and again, right? Like if you looked up a topic online and you found 10 articles, it'd probably repeat the same phrases, you know, 5 or 6 phrases in all of them, all of the scientific articles or all of the newspapers. So first it has to remove all of those redundancies. And then what it's going to do, it's going to look at what's left and extract the most important points so that it's able to make an argument. So how does Project Debater learn a topic? So it's actually not learning any particular topic, but it is very good at quickly creating a persuasive narrative based on available data. So think of like debate team, right? You may be asked like a random question based on very limited data. So it's Project Debater has access to volumes, large quantities of data, so that it can really build a really solid foundational persuasive argument. But it's doing it in real time, just like a person would. So the debater system was taught to debate unfamiliar topics. So it can debate many different topics as long as they are all well covered in the massive corpus. So there's a collection of written texts, especially the entire works of think Harry Potter. As long as we have access to the entire Harry Potter series, Project Debater can put together a very persuasive arguments in favor of or not in favor of, you know, Harry, for instance. So it's able to debate both sides, and having access to a body of writing on a particular subject and entire works that the system then mines. It includes hundreds of millions of articles from numerous well-known newspapers and magazines. So as long as it has access to all of that, it can debate all kinds of different topics. So how does it form an argument? So we know how it's getting data, but how is it actually forming an argument? So given a topic, the system is scouring this massive body of knowledge, looking for the most relevant points and evidence to support or contest the topic. It then picks the most compelling, diverse, and well-supported arguments and arranges them to construct a complete persuasive narrative. So the next question you might be wondering is, how does the debater system know if a claim is for or against the topic it's given? So this is one of the many aspects that makes Project Debater extremely unique. So it's been taught to understand the nuances of language and decide the stance of an argument given on the topic, right? So if someone might ask you a question and ask you to elaborate or give an opinion on it, you might not necessarily know which side it wants you to, or which side they're asking you to give an argument for. So Project Debater has been taught to understand the nuances of language in order to make sure that it understands which side of the argument it's being asked to give on the given topic. So imagine debating the pros and cons of the use of traffic enforcement cameras. So when given the claim, the photo radar program fails to provide any clear safety benefit, A human debater instinctively understands it contests the use of traffic cameras. But this type of understanding is really hard for AI. So the debater system approaches this by breaking it down into smaller tasks. So the system's going to understand that the photo radar program is associated with traffic enforcement cameras, and then it further is going to understand that the rest of the sentence, even though it includes positive words like safety and benefit, is in fact contesting the use of traffic enforcement cameras. So it's really sophisticated for a machine to be able to do that. So what is the format of the debate? So I'm going to show you the debate very, very soon, just a few slides. So the format of the debate. So it follows the format of a traditional debate. So Project Debater and its human counterpart, as you'll see, each present a 4-minute opening, allowed by a 4-minute rebuttal, and then it's given a 2-minute closing statement. So just like, if you were in debate team, same format. It's important to note that the debate topic is not known in advance. So Project Debater is not pre-trained on any specific data sets or any specific topic data sets or any specific topic content or information. Is the debater system actually listening to the human debater? So yes, as we mentioned before, it is listening using Watson's speech to text. So the system is identifying key concepts and claims as the opponent's talking to them. And as the opponent is giving their argument, Project Debater is preparing for their rebuttal. Project Debater can listen and digest long, continuous spoken speech, up to 4 minutes long. So it's actually listening the entire 4 minutes of the human opponent's argument. Can Project Debater argue both sides? So yes, like we mentioned earlier, and just like a human debate expert would, Project Debater can argue either side of an issue. It's able to find pros and cons based on the topic stance that it's given. So when presented with a topic like government should regulate artificial intelligence, it figures out which claims are for and which are against the statement. So for example, if Project Debater is arguing for the topic motion, the claim AI needs regulation to both protect individuals and accelerate adoption would be classified as a pro. And a claim like heavy-handed regulation of AI by any country will stunt its AI progress would be classified as a con. So it's able to extract that sentiment and weigh whether it's a pro and a con effectively. So because it's a machine, Project Debater is impartial. It isn't out to prove a position or be right. It doesn't have, deep-seated, morals and values that it grew up with, right? So it's just designed to help expand minds and help people see more than one side of an issue. So now, the moment we've all been waiting for, let's see it in action. This is very cool.
Is this: we should subsidize preschool. We should subsidize preschool. That's going to be the resolution. And I just want to say, in terms of what we mean by that, the way that we're framing it, we are not talking about preschool in any particular locale, no particular city or state. We are also not referring to any particular program that exists or any particular proposal out there. And finally, we are not talking about targeting or choosing preschool programs for any particular group of students in any particular place. So let's get started. I'm going to go to my lectern. And our first debater in round one will be Project Debater. A 4-minute introduction from Project Debater. Again, and Project Debater actually has a gender. She will be arguing for the resolution, we should subsidize preschool. Ladies and gentlemen, here we go, Project Debater.
Greetings, Harish. I have heard you hold the world record in debate competition wins against humans, but I suspect you've never debated a machine. Welcome to the future. I will argue that we should subsidize preschools. We are going to talk about financial issues, but not only about them. In the current status quo, we accept that the question of subsidies goes beyond money and touches on social, political, and moral issues. When we subsidize preschools and the like, we are making good use of government money because they carry benefits for society as a whole. It is our duty to support them. Subsidies are an important policy instrument. They provide governments with the means through which to pursue industrial development and ensure the livelihoods of their citizens. There are two issues I will elaborate on now. I will start by explaining why preschool is an important investment. I will also say a few words about poverty, and I will end by discussing some other issues that show the positive aspects of preschools. Regarding investment, nature-based preschools are powerful interpretive programs as well as lucrative business decisions. As I mentioned, preschool is an important investment. For decades, research has demonstrated that high-quality preschool is one of the best investments of public dollars, resulting in children who fare better on tests and have more successful lives than those without the same access. Secondly, a few words about poverty. While I cannot experience poverty directly and have no complaints concerning my own standards of living, I still have the following to share. Regarding poverty, research clearly shows that a good preschool can help kids overcome the disadvantages often associated with poverty. The OECD has recommended that government subsidize pre-primary education to boost performance in poor areas. A statistical summary of studies from 1960 and 2013 by the National Institute for Early Education Research found that high-quality preschool can create long-term academic and social benefits for individuals and society, far exceeding costs. The Centers for Disease Control and Prevention reports that universal full-day preschool creates significant economic savings in healthcare, as well as decreased crime, welfare dependence, and child abuse. Former Prime Minister Gough Whitlam said in 1973 that preschool is the greatest single aid in removing or modifying the inequalities of background, environment, family income, or family nationality. Now to an additional final issue. A study by the Melbourne Institute of Applied Economic and Social Research shows that attendance at preschool has a significant positive impact on later NAPLAN outcomes, particularly in the domains of numeracy, reading, and spelling. The results of a new study of over 1,000 identical and fraternal twins, published in Psychological Science, a journal of the Association for Psychological Science, confirmed that preschool programs are a good idea. Here is a study from New Jersey that is worth noting. In New Jersey, the follow-up to the Out of Preschool Program study continues to find that high-quality preschool programs increase achievement in language arts and literacy, math, and science through 4th and 5th grade. I hope I relayed the message that we should subsidize preschools. You will possibly hear my opponent talk today about different priorities and subsidies. He might say that subsidies are needed, but not for preschools. I would like to ask you, Mr. Natarajan, if you agree in principle, why don't we examine the evidence and the data and decide accordingly? Thank you for listening.
Ladies and gentlemen, Project Debater.
Very cool, very cool. Solid, very solid argument. So I would like to pass things off to Saishruti so that she can talk about some business use cases for Project Debater.
Yeah, thank you, Jenna. Hello again. So let's take a different perspective now. Let's shift the focus a bit, and now let's see a business use case that was developed with one of the debater datasets. Next slide, please. Okay, so previous slide. Perfect. So we'll be using one of the debater dataset for today's demo. The dataset is Sentiment Composition Lexicons, and it's available in Data Asset Exchange. Let me give you a quick overview of Data Asset Exchange, which we usually call it as DAX. DAX offers high-quality datasets with clearly defined data licenses. They are vetted data by we trace the origin, we learn about the quality of the datasets, usability rights, and ownership. Once, if you are satisfied with the initial research, we then create a metadata of the datasets with all the information that we have collected over our research period. And then we perform a comprehensive legal review before releasing the dataset. And that's what I mean, we provide better data. We also provide users an option to preview the data glossary, and we provide notebooks demonstrating the usage of the dataset. So this is all about our open source project called Data Asset Exchange. I will post the link to the project in the chat after my presentation. Next slide, please. Okay, so the dataset that we are going to see now, it's Debater Sentiment Composition Lexicons. So let's see what the dataset has. This dataset addresses sentiment composition. To be clear, we are going to predict the sentiment of the phrase from the interaction between its constituents. Let's take two examples. One is reduced bureaucracy and second one is fresh injury. Both reduced, in this examples, like both reduced in reduced bureaucracy and fresh in fresh injury are followed by a negative word. However, reduced flips the negative polarity, resulting in a positive phrase like reduced bureaucracy, while fresh word propagates a negative polarity to the phrase level, and it results in a negative phrase in fresh injury. According to this example, reduced is a part of we call reduced as reverse lexicon and fresh as propagator. It propagates the positive polarity, whereas reduced word, it propagates the negative polarity, right? And it's called reverses and it's called propagators. This is like a very simple example of what the dataset contains. Source of the dataset is, it's a large proprietary English corpus, and we have about 66,000 unigrams and 262 K like bigrams. Next slide, please. Okay, so coming to the business use case, right? So this dataset is also available under Cloud Pack for Data as external data source. For those who are not aware of Cloud Pack for Data, is a fully integrated data and AI platform that modernizes how business collect, organize, and analyze data to infuse AI throughout their process. So I'm going to walk you all through a business use case which we developed using two of the Debater datasets. We will walk through only the sentiment analysis part later in the presentation. For now, let's see an overview of the application. So let's say you want to enhance your customer experience by addressing their reviews quickly. You can use this application right before you to automatically group the comments or feedback from customers, as well as highlight their positive and negative sentiment of the reviews. So this application, for example, can be used in the retail industry and would allow, this would be a central place for the retailers to easily review the customer feedback in a much more organized manner. So that's a whole, point of this or the idea of this application. So I'm going to tell you which dataset is used in the which part of the application now. So once customer reviews are submitted to the site, in the backend, we will be organizing the post by the reviews by calculating the similarity between them. And we use IBM Debater thematic clustering of sentences dataset to cluster the reviews and put it into different groups, into different buckets. Additionally, when we are reviewing the feedback in different buckets, we are also providing you an option to highlight sentence level sentiment, so that it's easy to categorize the feedback on a sentence level or as a whole with a wide range of sentiments. So that's a whole goal of this application. It can be used in your customer care use case. Right? Next slide, please. So this is a very simple UI for an application. You can see the reviews are being automatically grouped together, and the image at the bottom is where we are predicting the sentiment of the reviews. Next slide, please. Perfect. So now I gave an overview, and I would like to pass over to Jenna again, and she's going to show the demo of that. Thank you.
Okay, perfect. So let me switch my view here. So if any of you would like to take a look at the actual data sets and the notebooks and kind of work through them. So what I'm going to do is I'm going to show you how to get them set up, and then Evan's going to walk you through what's going on in the actual data sets. Okay, so there we go. Okay, oops. Okay, so I posted the link for the IBM notebook and data set. What you should see here is you should be on this screen. So the first thing you're going to need to do is create an IBM Cloud Account, which again I posted at the very top of the chat. Also, if you click the button at the bottom center that says click to check in, that'll take you there as well. So the first thing that you're going to want to do when you log into your IBM Cloud Account, if you don't already, you're going to need a Watson Studio account. So you can type in Watson Studio in the search bar right at the top. So when you sign in, this is the dashboard, the first view you'll see. So you'll go down to this Watson Studio icon. And then again, we have a light tier for Watson Studio as well. So you don't need to do anything. Select the light tier option that already has a check mark there. And at the bottom, I always recommend people put like their initials or something by it. If you work on a team or in a work account, like as you can see here, I have a lot of other people that are in the account. So as you can see in my search, there were a lot of instances. So the other thing you need to do is click create. And then the next view you will see is instance. And if you already have a Watson Studio account, it'll come up when you search at the top. So there's my instance. You can see all the other ones. So then you'll be here. So the next thing I want you to do is click on that link, that IBM Debater notebook link that I posted in the chat just a few seconds ago, and it'll take you here. So this is the, you can get the data set, you can preview the data in notebooks. What I'm going to show you how to do is actually run the data set. So when you click Run Dataset Notebooks, it's going to take you here. So what you're actually going to be able to do is create a Watson Studio project. And as you can see here, it already has a name because I have one. But it will automatically enter in the name, the description, and then the only other thing you'll need to do is select your cloud object storage. If you don't have object storage, there will be an indicator here, a link to create one. So you'll just create that quickly and then reload. And then you'll be able to select your cloud object storage from the dropdown. So when you create that project, you'll be taken here. So here is my own personal IBM Debater Sentiment Composition Lexicons project that has all of the information, resources, data sets, notebooks, has everything in here. And now I can do whatever I want to do with it. I can run the notebooks. Here are the data sets. And here are the actual Jupyter Notebooks here that you can actually run and work through. So if you want to go ahead and get that set up to play around with it and follow along, feel free. Feel free to also experiment with it a little bit on your own time. The next thing I would like to do is pass things over to Eva so that she can go through what we're looking at here. So
Sure.
There we go.
Sure. Okay. So
Sure.
let me share my screen right now.
There we go.
Okay. Cool. So you can see there are two notebooks in the project. The first one is the Load and Visualize IBM Debater Sentiment Composition Lexicons. The second one is the model development. So let's get started with the first one. I will quickly introduce you what's the purpose of the notebook and what it does. Okay, so in the part one notebook, firstly, we load the data in the table of contents, and also we visualize the data. So in the data set, there are U-grams, unigrams, and bigrams. We want to firstly know how they look like. How are the distributions of the unigrams and bigrams? Because we don't want our data is biased. And also this is some basic data analysis exploratory before we really want to go in there and develop a model. So the first step is always to do some basic data analysis on it. Okay, so also quickly go through what kind of data set we have in here. So we will handling the lexicon unigram text and lexicon bigram text. So this is the unigram data set. This is the bigram. In the part one notebook, we will not touch on the sentiment part because it will make things kind of complicated. Okay, so going to the lexicon unigram data set. Firstly, this is how the data set look like. There are two columns. One column is unigram. The other column is the sentiment score. So the sentiment score means how positive or how negative the word is. So some of it you can see this is like really low number around 0. It means it is neutral. And if you see something around really close to 1 or really close to -1, 1 means it's positive and -1 means it is negative, like it is something negative that's in a word. So this is calculated in the research, and we just have the data set because of the research, the publication of the research. And also in the bigram, we introduced the post-tags because there are two words. What are the relationship between the two words? And also as well, we have the sentiment score, how positive or how negative the sentiment is. Okay, so after loading the data in the part one, let's get through the data visualizations. So in the unigrams, we firstly categorize the sentiment score into the positive or the negative. So it is categorized by, is this larger than 0? If it is, then categorize as positive. And if it is smaller than 0, then that's going to be negative. And we assign negative as 0. So it's basically like a dummy variable that you can think of. Then we want to plot the distribution of the sentiment polarity. So this is to show how the data is balanced. Sometimes if you have too much of positive words or too much of negative words, the data set wouldn't be balanced. And when you train a model on it, it would give you some biased result. That's something we don't want to have in the model when we go to the part 2 notebook. So we just check the polarity of the sentiment. And also, this is something out of curiosity to see what's the length of the unigrams. Okay, so we can see from here that most of the words are around length 7 or 8. And this is also like a really well curved bell shape of the unigram length. And also something also out of curiosity to check what's the first letter of each unigram word, and how many of them are starting with A, starting with B, starting with C, and how are the sentiment of each word. So this is to group by the first letter and also group by the sentiment. We got the table, and then this is the distribution, how it look like. So this is by the first letter. You can play around with it if you are interested in like what's the ending of it. Yeah, and also going to the bigrams, this is something really similar to what we had in the unigrams. Firstly, also to categorize what's the sentiment score, is this positive or this is negative? And going into polarity, this is something like interesting because we have nothing like exactly 0 because there are 2 words. There's like nothing super neutral like, oh, you have a score 0. So this is also something we found out in the bigram sentiment score. And also, this is the pulse tag. And we want to see how many pulse tag for each of the, for all of the bigram words. So how many of them fall into this JJ / JJ category? And for all of the pulse tags, what are the distribution of the sentiment? How many are positive and how many are negative? So the ones that are yellow are positive, which is 1, and the ones that are blue are 0 because we classified the data set into either 1 or 0. So this is how it looked like. This is also to check if the data is balanced and if this is something really weird that we should check before we go into modeling. And this is another way to count the pulse tags, but they're so similar to each other. Okay. And these are checking the first letters of all of the bigrams, and this is similar as what we did in the unigrams. And after all of these, we save the clean data as unigram.csv and bigrams.csv. We do that because previously we have a sentiment score that's either 0 or 1 saved into the data set, and that's what we want to have in the part 2 notebook. Okay, now let me switch back to the part 2 notebook. Okay, so can everybody see my screen? Yep. Thanks, Jenna. Okay, so let's go into the part 2, which is more of a fun part, sentiment analysis. So at the beginning, because we saved the 2 data sets that created in the part 1, we want to load them into the part 2 notebook. They are already in the project, and we just want to load them in. So those 2 are the unigrams.csv and bigrams.csv, and the other 2 data set that was in the project that we didn't touch on in the part 1 was the adjectives this Excel and also semantic classes Excel. So we will work on these in this part. And firstly, we also had 5 sentences that we want to use as testing. We will use these to calculate the sentiment score of each of the sentence. For example, how would the model calculate this sentence? Customer service was polite. It was supposed to be something positive, but is our model going to be accurate and give something similar result to that? So that's something we will use for this comment. Okay, then going into the bigrams, this is to check what we have in a data set. And then we calculate the unigram sentiment, firstly by tokenize the sentence. This is a function we create, tokenize the sentence, and add up together the sentiment of each of the word, and then give a result out of it. So for example, the first one, customer service was polite. Okay, this is something positive. Then it is 0.79. It is almost to the score 1. So I would say this is pretty good. And yeah, this is just a few examples to show you is this a good model or not. And then going to the bigrams, we do something similar as well. We create a function, calculate bigram sentiment sentence, and also calculate bigram sentiment. So these two calculate the bigram sentence, and then we test out how they are calculating it. And there are more information here, so if you guys are interested in trying it out, please go ahead and do so. I would say this is pretty fun to play around with, and even you can give into another comment or something else. For example, here, something new to try out. It would give you something really interesting to explore. So at the end of this notebook, you will know how to infer sentiment from unigrams and bigrams, and how to use those two data sets, the adjectives and semantic classes to infer sentiment, and also how to infer sentence level sentiments, combining all of the concepts. So I think that's everything in the notebook. I didn't go through everything, but I will leave it to you all to explore and have fun. Okay, back to you, Jenna.
Thank you so much, Eden. Okay, so I had a few questions. Just to be clear, so what Eden just showed you is part 1 and part 2. So they're generated as separate notebooks. So that IBM Debater notebook and dataset link, when you create a new project, both of those notebooks, one notebook will be part 1, one notebook will be part 2, will be listed under assets if you scroll all the way down under your notebooks tab. We did have one question that was posted here. If possibly Eden or Saishruthi, you could answer. It says, what is the error rate on identification of claim orientation? How well does it perform on grammatically complex or semantically nuanced sentences?
Sorry, I didn't see the question.
That's okay.
In the comment.
If you click on the Ask a Question button, the first question.
I see. Okay. Yeah. So what's the error rate on? Okay, we didn't calculate the error rate in these two notebooks, but definitely you can try it out. And if any questions, you can contact us or feel free to reach out to us. Yeah. And also these two notebooks, I remember, is based on the publication of IBM research based on this data set. So they are kind of correlated. Yeah.
Cool. Very cool. Thank you so much. Let's see. There we go. So congratulations to all of you. So what you've just witnessed and gone through is you've learned a little bit about NLP, natural language processing, and NLU, natural language understanding. You have also learned about Project Debater. You've also learned a lot about NLU sentiment and sentiment analysis, which is all really cool. So I would like to congratulate you all for making it to the end and getting your hands dirty a little bit. I would like to share with you all, there we go, if you would be so kind, while we're wrapping things up, we have a very short, oh, hold on. You can't see my screen. Let me fix that for you. Sorry about that. Okay, now we're going. Okay, now you get congratulations. Give yourself a pat on the back. This stuff is very complex. You know, it's complex. It's difficult to learn. It's difficult to understand. But you're all now that much smarter and wiser. So I would like to ask you all to if you'd be so kind, take a very, very short sorry about that, I had a weird message. A very, very short 2-question survey. I would also like to share with you, if you would like to connect with myself or any of the speakers, if you have any questions or you have any trouble or you've come across anything, please feel free to reach out to us. I'm going to post that right now in the chat. There we go. Oop. Now here we go. Feel free to connect with us. We can answer any questions. Even posted the rest. She posted the research paper. I will add that to the slides and resources that I have here. So just to kind of close things out, I've shared the feedback survey already in the chat. Here's some asset links that Evan's provided for us. I will update with the research paper as well. Here are the event resources. So if you'd like to do this later or share with someone else who might be interested, we have the cloud sign-up link, the slides, and the crowd class link where the recording will live. We also have, again, those data science certifications from IBM. Highly recommend. And if you liked our content here, feel free to follow any of our social media. So we have different meetup groups depending on which, I'll say, which geolocation. If on the East Coast, we have something for you. Since everything's virtual, you're able to attend any and all events that you would like that align with which times work better for you. We also are on Twitter, Twitch, and YouTube. I will be uploading this content, and you can view my previous content on data, machine learning, AI, containers and OpenShift, and cloud native development on my personal YouTube channel, which I've shared with you all as well. Just check here. So thank you all so much for coming. If you have any other questions or anything else that I can help you with, feel free to reach out to any of us on social, and I look forward to seeing you all next time. Thank you so much.